everyone, welcome back to my YouTube channel. This is Lolita P studying in Sri Venkateshwara College of Engineering. Today I am here to tell you about the ANOVA technique in mathematics for computer science. The ANOVA technique. The ANOVA is an analysis of variance, and it is a powerful statistical method used to test differences between group means. It helps determine if these differences are statistically significant. Types of ANOVA. There are two types of ANOVA, that is one-way ANOVA and two-way ANOVA. A one-way ANOVA is a statistical method used to compare the means of three or more independent groups to determine if there is a significant difference between them. It helps in understanding whether any of the group means are statistically different from each other. If you want to test if three teaching methods affect math scores differently, a one-way ANOVA can determine if the average scores for each method significantly differ. It is often used when you want to test a single independent variable across multiple groups. Two-way ANOVA. A two-way ANOVA is a statistical test used to examine the effects of two independent categorical variables on a continuous dependent variable and to determine if there is an interaction between them. It tests if the interaction between the two independent variables affect the dependent variable. For example, if you're testing the effect of study method A versus method B, the study's time short versus long, on test scores you could see if either method or time impacts scores and if there's any combined effect. The key concepts of ANOVA. Those are hypothesis, variance, between group, variance, within group variance, F ratio and P ratio. Hypothesis. There are two hypotheses. Those are null hypothesis and alternative hypothesis. Null hypothesis assumes that all group means are equal, meaning there is no significant difference among them. Alternative hypothesis assumes that at least one group mean is different. Variance. In ANOVA, variance measures the spread or dispersion of data within each group and between groups. Between group variance measures the variation between the sample means of different groups, indicating how much groups differ from the overall mean. Within group variance, this measures the variation within each group, indicating how much individuals in the same group differ from the group mean. F ratio, also known as F statistic. This is the test statistic in ANOVA and is calculated by dividing the between group variance by the within group variance. A higher F ratio suggests a greater likelihood that there is a significant difference between group means. P-value. The probability value that helps determine the significance of the test. If the p-value is less than a chosen significance level, the null hypothesis is rejected, indicating a significant difference between group means. Assumptions of ANOVA. Those are independence, normality, and homogeneity. Independence. The observations in each group are independent for each other, and normality because the data in each group should follow a normal distribution. Homogeneity of variance because the variances within each group should be approximately equal. Applications of ANOVA. ANOVA is used in various fields like biology, psychology, clinical research, and many more to analyze data. In biology, analyzing growth rates of different plant species, and for psychology because of comparing effectiveness of different therapy methods. And in clinical research, it helps in evaluating efficiency of new medications across patient groups. Let me tell you an example for one-way ANOVA. Let's take the scenario as we're trying to access whether different types of tea have an effect on weight loss. We want to see if drinking green tea, black tea, or no tea at all results in different levels of weight loss. Groups. We have three groups in this study. That is, one group drinks green tea, another drinks black tea, and the third group doesn't consume any tea at all. Objective. Our objective is to determine if there are significant differences in the average weight loss among these groups. If there is a difference, it could suggest that the type of tea consumed influences weight loss. We are using a one-way ANOVA test here because we want to compare the means of more than two independent groups to see if there is statistically significant differences. This approach should make the slide content clear and help the audience understand the purpose of the ANOVA test in this context. Let me give you an example for two-way ANOVA. The scenario. The study aims to evaluate the impact of gender, male and female, and interview stress, example low, medium, high levels, on salary outcomes. Groups. The participants are divided into subgroups based on male and female and the stress levels, different levels of stress during interviews. Objective. The goal is to determine how gender and stress individually influence salary, whether there is an interaction effect between gender and stress on salary. Why two-way ANOVA? Two-way ANOVA is used when there are two independent variables, in this case gender and stress, and a single dependent variable, that is salary. It helps in analyzing the individual impact of gender and stress, whether the effect of one variable, that is stress, on salary changes depending on the other variable, that is example. This approach ensures a deeper understanding of how multiple factors work together to influence outcomes. Conclusion. Powerful tool. ANOVA is a statistical method that helps in understanding the impact of categorical variables, example gender, stress levels, on continuous outcomes, example salary, test scores. It is specifically useful when comparing multiple groups to determine if there are significant differences between them. Versatile application. The ANOVA is widely applicable across different scientific fields such as social sciences, example studying the effect of education levels on income, and biology, example analyzing the effect of different diets on weight loss, and in business comparing the effectiveness of marketing strategies. It is used to analyze experimental data and draw meaningful conclusions. Statistical significances. ANOVA determines whether the difference between group means, that is averages, are statistically significant. This means it helps in deciding whether the observed differences are due to random chances or a real effect of the variables being studied. In summary, ANOVA is a versatile, robust method for comparing groups and identifying meaning patterns in data. Thank you everyone. Thank you for watching the video. I hope you liked the video and the video is very useful to you.